respectability. The milkman, the paperboy, evening TV. Did I get delivered here? Somebody tell me, please. This whole world confusing me. Clouds as mean as you ever seen. Ain't a bird who knows you're true. Then a little voice inside you whispers, don't sell your dreams so soon. Everywhere you look, there's a heart, a hand to hold on to. Everywhere you look, there's a face of somebody who needs you. Everywhere you look, when you're lost out there and you're all alone, life is waiting to carry you home. Everywhere you look, and everywhere you
All right. Here we go. Lesson 1-4. Our learning intention for today is I will be able to use visual models and equations to divide fractions.
Awesome. And so at the end of our lesson, to know that you're successful, you will be able to do two things: use models to divide with fractions, and also use equations to divide fractions. All right, so let's go into those notes.
Topic 1-4 essential question is how can you use models and equations to divide with fractions? Perfect. We just have one vocabulary word, reciprocal. Reciprocal is a pair of numbers that when multiplied together equal 1. Cool. So for example, 2, our whole number 2, it's always over 1. We've reviewed this before. If we find the reciprocal of 2 over 1, that's 1 over 2 or 1/2. When we multiply this straight across, 2 times 1 is 2 and 1 times 2 is 2. So 2 over 2 is just 1. That's why when multiplied together, a reciprocal always equals 1. All right, guys, so let's jump into example number 1. Mr. Roberts has a board that is 3 feet long, and he plans to cut the board into pieces that are each 3/4 foot long to build a set of shelves. How many shelves can he make? All right, so let's look at this 3 feet long. That's how, in entirety, how long the entire board is. And Mr. Roberts wants to cut this board into pieces that are each 3/4 of a foot long, right? And he wants to use as much of the board as he can. So we need to know how many pieces can he build to build some shelves, okay? And how many shelves can he make? So our two values that we need to look at are 3 and 3/4, okay? And we want to know how many 3/4 are in 3 feet. All right, so we have our total, which is 3, and our pieces, which is 3/4. So we're going to use a number line to help us solve this. And we're going to show, on our number line, we're going to show 3 whole values, right? So we're going to use tick marks to represent and cut our number line into 3 pieces. So each of these whole numbers, the 0, 1, 2, and 3, is measuring in feet. So we have 3 feet, which is why we stop at 3. Now within these 3 pieces, right, 1 foot is what's represented on the number line. We're going to divide each foot into parts of 4 because we're trying to figure out how many 3/4 of a foot we can get. So we're now splitting each foot up into 4. And then we want to use all of the wood, right? So we're going to group 3 of those tick marks together. And we're going to keep going to see how many groups, how many pieces we could get out of this 3 feet. So Ms. Flemington is circling those 3 pieces in blue. So we have 1 3/4, 2 3/4, 3 3/4, and 4 3/4. So when we divide, and we want to know how many 3/4 are in 3, we know that there's going to be 4 3/4 and 3 whole feet.
Excellent. So a lot of times you will get a visual model, or you will have to be asked to represent your equation in a visual model. But we have been blessed with a little thing called an algorithm, right? Whenever you see a division problem, right, when you divide a fraction by a fraction or a whole number by a fraction, there is a formula that you are going to follow, okay? So for example, if the above problem is 3 divided by 3/4, we are going to use this simple little rule that will always allow you to arrive at the correct answer, okay? So the first step is keep the first number the same. We're going to set 2, change the division sign to multiplication, and then step 3, you're going to flip the second value, which is known as finding the reciprocal.
So this is another strategy that Ms. Flemington is showing right now. She's going to show us how all these steps look when we go and solve our problem.
So what I like to do is add on the very top of my values, kind of like a little checklist. So I'm going to keep the first number, so bringing it down. Okay, keep that 3. But now we have a whole number. What is our rule when you have a whole number? Every whole number, anytime you're multiplying or dividing, you always want to turn that into an improper fraction by adding a 1 on the very bottom, turning it into a fraction. Then you're going to change that division sign to multiplication, and then you're going to flip it. So keep, change, flip that second number, find the reciprocal. So 3/4 turns into 4/3. Oh man, now we know how to multiply fractions, don't we, Miss Conrado?
Yes, we do.
What do we do? Oh, we multiply the top straight across, and we multiply the bottom straight across. So 3 times 4 is 12, and 1 times 3 is 3. And we see an improper fraction here, 12/3, 12/3, we know can be simplified because 3 goes into 12 4 times, 4 wholes. So our answer is 4, right? So with the visual model and with the algorithm, we still arrived at the same answer. And so on the side here, guys, you will see that what the algorithm is, and it has a step-by-step checklist that you will be able to reference if you do get stuck. First, you keep the fraction as is. If it's a whole number, change it to a fraction by putting the whole number over a 1. Step 2, change the division sign to multiplication. And step 3, find the reciprocal of the second fraction, which simply means, right, turning, if you have 2/1, you want to change it to 1/2. All right, so let's go down to example number 2.
All right, so in example number 2, how much cake will each person get if 3 friends decide to share half a cake equally? Okay, so find 1/2 divided by 3. All right, so here we're going to draw a picture just to show 1/2. Okay, so we have our whole cake, and we're going to split it in half, right? And then we're just going to shade in just one piece because that will represent that one part of our total, which is 2. We have 2 total, or just 1. Okay, now we're going to divide that 1/2, that half of the cake, into 3 equal parts, right? So we'll draw that horizontally. And then each part of the whole, right, we're just going to circle 1. And how many are there squares? How many do we just divide that cake into total? There are 6 parts total, and there's just 1 of that part that each friend will get, right? If we share it equally. So that should now be 1/6. So using our algorithm, we just want to make sure that we also arrive at 1/6 when we solve, right? So if we keep, change, and then flip, we should get 1/6. So let's keep our fraction of 1/2. We leave that alone, we keep it the same. We're gonna change our operation from division to the inverse, which is multiplication. And then we're gonna flip our second fraction, and every whole number, right, is always over 1. So we're gonna flip it, right, do the reciprocal. So now we'll flip it to 1/3. So that was kind of 2 steps, right? Making sure that that was over 1 and then flipping it to the reciprocal, which is 1/3. Now we could just multiply just as normal straight across. Our numerators, 1 times 1 is 1, and 2 times 3 is 6. Now, did we arrive at the same answer? Yes, we did. Each person will get 1/6 of the cake. Let's jump into our triads. We're going to look at quadrant 1. We're going to see that a board is 6 feet long. That's our entire board. How many 2/3 foot long pieces can be cut from the board? And we're going to use this number line to show our work. And we can totally do it. So Miss Flemington already did labeled a lot of the parts of this number line for you, okay? So first, she's showing us 1 foot, right? 6 1 foot pieces, I guess, using the entire number line, right? So that's what we would see in a normal number line. And then we're going to take each of those, each of that foot, of the 1 foot, right, of the 6 feet, and then we're going to cut it into thirds, because we need to figure out how many 2/3 foot long pieces we can get out of this entire board. Okay, and then we're going to see how many. So we're just going to group these now into 2, because that's what our denominator says, 2/3, right? So when we go along, we see that we have 1, 2, 3, 4. We're circling them in blue. 5, 6, 7, 8, 9. So why is the number of pieces that can be cut from the board greater than the number of feet in the length of the board? Well, this is because we're grouping everything that we just cut this board into by 2s. So it doesn't matter, we're not saying that now we have 9 feet, we're saying that we have 9 2/3 foot long pieces that we could cut 6 feet into. Okay, so we're grouping our part to total of the 2/3. Perfect. So now let's just use this algorithm to solve this, just to make sure we can check and arrive at the same answer of 9. So we're going to use our keep, change, and flip. We're going to keep our first fraction, right? 6/1. We're going to change our operation to multiplication. And then we're going to flip 2/3. And if we flip that, we'll have 3 halves. Now we could just multiply straight across. 6 times 3 is 18, and 1 times 2 is 2. When we simplify that, we know that 9 groups of 2 can go into 18, so our answer is 9. Check. It's a good match.
Woo! We did it, guys. We did it.
Make a work with diagram, so now we're going to make our own diagram to find 2/3 divided by 4. All right, so we're going to take our first value, which is 2/3, and that's what we're going to first represent on our number line. So Ms. Flemington did that in red. So our number line is going to be broken up into thirds, okay, until you get to 3/3 or 1 whole, okay? And then you'll take, if we realize that 4 is going to be 4/1, but later in our algorithm, we're going to flip it to 1/4. So because we know that we're going to flip it later when we do our algorithm, that's what we need to just kind of get used to thinking about when you say, now what do I split this into? Or you can know that you're going to split them into fourths, right? Each piece, you're going to split them into 4s. So that's what Ms. Flemington did in black. Okay, so then they want to know they want us to find 2/3. Okay, so they just want us to find 2, okay, of this total. They don't want us to pair up of how many groups of 2. They only want us to find 2. So when we do circle 2 of these tick marks, just 1 and 2, And now how many do we have total? How many tick marks did we split this into, or parts did we split this number line into total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? So we have 2 over 12 represents 2 divided by 4, right? That's our answer. We can simplify it to 1/6 because 2 goes into 12 6 times. If we divide 2 by the top and the bottom, we know that that gets us 1/6. So let's use our algorithm just to make sure that we get 2 12ths and then we simplify that to 1/6. So if we keep change and flip, we keep 2/3 as is. We change our division to multiplication. And then we flip, like we had talked about earlier, our 4 over 1, we do the reciprocal to 1 over 4. Now we can multiply straight across. 2 times 1 is 2, 3 times 4 is 12. We simplify that to 1/6. Check, we did it.
Woo! We did it. That was long. But we made it through, guys. You guys have now mastered division of fractions.
And guess what? As your prize, you could do quadrant 3 and 4.
Prizes. We're gonna have prizes, Miss Conrado.
Oh, yeah.